Okay, 3.3 is the title's measures of relative standing. So what we mean by relative standing is you're going to be able to compare not just a specific number, but more as a percent and in terms of your standard deviations. So this provides a way to compare data. So that's why it's called measures of relative standing. So z-score is the first way that we can look at how each data value compares. So it's going to be the number of standard deviations a given x value is above or below the mean. So remember, the mean is your x bar. So this is going to be a way to compare your x value to your mean, z-score. So the way that you find it, this is our formula. Your data value minus your mean, divide by standard deviations. So remember, standard deviation is how far above or below a value is from your mean. So you're comparing it to your mean. So x minus x bar and divide by your standard deviations. This is going to get you how many standard deviations that value is either above or below the mean. Whenever a value is less than the mean, its z-score is negative. So let's say your z-score is negative 1.5. What that means is that your x value is 1.5 standard deviations away from your mean, and it's below. So this is below x bar. 1.5 standard deviations below. So when we looked at our empirical rule with 3.2, remember the mean is in the middle and then x bar plus s. This would be a z-score of 1 because it's 1 standard deviation above. This would be a z-score of 2. This would be a z-score of 3. If we go back to the left, this is below your mean. And so your z-score here would be negative 1. This would be negative 2. This would be negative 3. Because it's how far away it is from the mean. And how in the units is standard deviations. Like it's 5 feet away. Well, we're talking about our units being standard deviations. It's 2 standard deviations away from the mean. So that's what a z-score is. So ordinary or usual values. Remember, that's our 95%. It's between above 2 standard deviations or below 2 standard deviations. So ordinary or usual values have z-scores between negative 2 and 2. So unusual ones would be outside of that boundary. So I would say beyond negative 2 and 2. So beyond, this would be like below negative 2 or above 2. We'll round z-scores to 2 decimal places, and they're expressed with no units of measurement. So we just say z equals blank. So like I was saying with our empirical rule, this is 1 standard deviation below, 2 standard deviations, 3 standard deviations. Right here is our boundary of ordinary or usual values, and anything outside of that boundary is considered unusual. We could also say they're outliers or extreme values. Example 1. With a height of 67 inches, William McKinley was the shortest president of the past century. The presidents of the past century have a mean height, so I'm going to put X bar equals 71.5, and a standard deviation, S, equals 2.1. What is the difference between McKinley's height and the mean height? So we would take X minus X bar. So X is one of our data values. So that is 67. That's McKinley's height. So we would say 67 minus 71.5. So that's 4.5 inches. How many standard deviations is that? The difference in his height from the mean. So the way we would do that is we would look at what's the standard deviation? 2.1. So if it's 4.5, about how many standard deviations? So it's more than 2. Below, right? Oh, this should be a negative. I forgot my negative because it is below. So to find the actual z-score, and that's how many standard deviations it is away, we use our formula. So we've already subtracted, but let's go ahead and put it in the formula. So S is our standard deviation. So we take the difference, and then we divide by our standard deviations. Stick that in the calculator. And we're rounding to 2 decimal places. So negative 2.14. So that's our z-score. So a question is this considered usual or unusual? It's unusual because it is below negative 2. Remember, that's our boundary for usual, negative 2 to positive 2. So he was unusually short compared to the rest of the presidents in this century. Example 2, IQ score. So it says the IQ score has a mean of 100. So let's write X bar equals 100 with a standard deviation of 15. We talked about that a little bit in the last lesson. A psychologist tests a woman's IQ and finds that it is 121. Find her z-score. So X is 121. That's our sample value, or from the sample. So our z-score is found by subtracting X, which is 121, minus 100, and divide by 15. So we know 15 is our standard deviation, so it's a little bit above 1. What is it? 1.4? That's it? So 1.4. So is that considered usual or unusual? Usual. Because it's between -2 and +2. Let's look at quantiles or fractiles. So what we are going to do with quantiles is break the data up into 4 quarters. Break up the data into 4 quarters. And this is going to help us be able to draw a box plot, box and whisker plot. It's probably been a while since y'all seen that. I think I taught it in 8th grade, 7th grade, and 6th grade. But that was probably the last time. So middle school was the last time you've probably seen this. So we are going to use the median. The median is going to cut it in half. So, of course, we need to line them up in ascending order and find the middle. So for quartiles, you're finding the median. The median is going to help you be able to break your group up. So 50% of the values are equal to or less than the median, and 50% of the values are greater than or equal to the median. Then we're going to break it up again. We're going to look at the top value. So look down at this little image right here. So right here is your median, right in the middle. And this is really percents. So you find your median, and then you look at quartile 1 and your median, and you find the middle of that. So your minimum and your median. Find the difference between your minimum and median. And then you do the same thing with your maximum. And the way we are actually going to make a box plot, we are going to use a number line. And numbers are going to be here. This is our minimum. This is quartile 1. This is quartile 2, which we normally just call it our median. And this is quartile 3. And then that's our maximum. And your box plot comes from making this line right here and putting a box around quartile 1, 2, and 3. And that creates a box and whisker plot. So we can actually get all of these numbers, minimum, quartile 1, median, quartile 3, and maximum, all from our calculator. This is actually called the 5-number summary. 5-number summary. All right, so let's put that data in. And this is different data than we've dealt with before. It doesn't tell us where this information comes from. Oh, yeah, it does. Use the following sample of ages from 11 wild bears to find the min, quartile 1, median, quartile 3, and maximum. One, 2, 3, 4, 6, 7, 8, 9, 10, 11. So once you get your list in there, go ahead and go stat, calc, one variable statistics. So our minimum is 19. Quartile 1 is 53. Median is 57. Quartile 3 is 100. And max is 115. All right, we're going to skip example 2. Let's go on to percentiles. So this is P sub some number, let's say K. This is going to be your percentile. So if I say P1, that means 1 percentile. So whenever y'all take your SAT, ACT, they give you your percentile rank. And what that means is how much higher are you in your score from everyone else. So let's say you had a 98 percentile. That's really high. That means that you have a score that is 98% higher than everyone else's in that sample, or it'll tell you what the sample is or what the population is. So percentile X, it's going to measure the location in comparison to all other data values. So it's finding a percent. This is your percentile. So the way you're going to do that is this is going to be a fraction. So percentile value of X, you're going to find all of the number of values less than X and divide it by your total number of values. And then convert that to a percent. So times 100, or move the decimal over 2 places. So we're going to round it to the nearest whole number. So like 10%, 12%, 56%. I don't want any decimals on that one. Percentiles tell you the percent of data that is at or below a given value. Make sure you arrange the number in order from smallest to largest before finding the percentile value. So let's look at our first example. This has Old Faithful. So we have this as our data values. It says find the percentile of 90 minutes. So basically, how many values are less than 90 minutes? This data has already been arranged in order for us. So we're just going to look and see how many. There's only 2. So to find your percentile of 90 minutes, we would do 2 out of our total 12. Which it's 0.16 repeating. So that's going to come out to 17%. So the way we would write this, we would say percentile of 17 is 90 minutes. So an eruption of 90 minutes is at the 17th percentile. So 90 minutes is only above 17% of the data. So let's look at the next one. Find the percentile of an age of 81 for a bear based on the following data. So we are saying P of what gives us 81. So we're looking at how many values are less than 81. So put a little box around all those values. So 7 of them out of 11. So that would be 0.636, which would round to 64%. As you move your decimal over and round up. So P64 is 81. So the age of 81 is in the 64th percentile. So it's higher than half. So an age of 81 is more than half. Okay, so let's go the other way. How to convert from a given percentile to a corresponding value. So you'll sort the data from lowest to highest. And then you will do K over 100. So K is your percent. K is your percentile. N is your number of values. If L is a whole number, then you add L. So L to the value. So we're going to have to do an example for this, which I think it's on the next page. And then if it's not a whole number, you're going to change L by rounding it up to the next larger whole number. And the value of PK is the Lth value, counting up from the lowest. So these quartiles from here, so we can use our calculator and do one variable stats, or we can look at these as percentiles. So quartile 1 is your first quarter of the data. So that's 25%. Quartile 2, that's your median. That's 50%. Quartile 3 is 75%. And then you have your min is 0%, your max is 100%, your highest. So if I want to find quartile 1 without using the calculator, I'm going to do my K, which is my percent. So 25 out of 100. And then multiply that times how many values I have. So that's times 12. And that gives us 3, because that's 1/4 of 12. If you multiply that out, that gives you 3. So my quartile 3 is my third number. See if it says it's a whole number? By adding the Lth value and the next value and dividing by 2. So Lth value is 90. And add the next, so this is my third value. So I'm going to add it to my next value, 92, and divide by 2 because it's halfway between these two. Well, halfway between 90 and 92, just 91. So quartile 1 is 91. We can also write this as P25. Percentile of 25 is 91. '50th percentile would be 50 out of 100 times 12. 1, 2, 5, 6. So this comes out to equal half of 12, 6. So we go back up here. It says if it's a whole number, we're going to add this value, that's the Lth value, and the next value and divide by 2. This is my 6th value. Add it to my 7th value and divide by 2. $93.5, yeah, 93.5. So this is actually my median. So we could say P50 gives us 93.5. And then 75th percentile rank, 75 out of 100 times 12. 3/4 of 12, 9. And you can use your calculator on this. So now I need to find the 9th. And this again is a whole number, so I'm going to do 9th plus a 10th divided by 2. And that's 95.5. So P75, 75th percentile is 95.5. So this is also considered quartile 1, your median, quartile 3, sorry. Okay, let's find the 90th percentile if we take the outlier of 65 minutes. If we take out the outlier of 65. So now we no longer have an even number of data values. We have the odd number. So 90th percentile, P of 90, is found by doing 90 out of 100. And then multiply times how many values we have. Now we only have 11. I need to make that into a decimal. 9.9. So this is the first time we've had a decimal answer. Normally we have a whole number answer. We add it to that next value and divide by 2. But when we have a decimal answer, it tells us round up to the next larger whole number. So this would be 10. So the 10th value is going to be our P90, our 90th percentile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it equals 98. So the 90th percentile, the data value in that percentile is 98. Okay, let's skip this. Let's do our interquartile range. This is also called IQR, interquartile range. This is found by subtracting quartile 1 and quartile 3. So we'll actually write it as quartile 3 minus quartile 1. And where this comes from is, remember how I talked a little bit about that box plot over here? Your IQR is found by subtracting that box. The maximum from the box and the minimum from that box. So whenever we do that box plot. Okay, we really don't use these much. So we're not going to use that. We're going to move on to determining if a value is an outlier. The formula for this is you're going to first find your IQR. So find your IQR and then multiply it times 1.5. Once you find those values, you look at above that value, 1.5 times IQR, and then go below quartile 1 by that value. Okay, so we're going to do this. We're going to use our calculator to find our quartile 1 and quartile 3. So go to Stat, Edit, let's put that data in. I'm going to clear out what's in L1 right now. 12 values you should have in there. So all we're doing is finding an outlier, finding out what an outlier would be. So once we find this, or once we put that in, go to Stats, over to Calc, one variable statistics. Let's find quartile 1, 155. Quartile 3, 346. So let's find the IQR. So that's going to be 346 minus 155. $191 is our IQR. So to determine if we have an outlier or not, we do IQR times 1.5. So 191 times 1.5, 286.5. So to figure out above that, we would do Q3 plus that 286.5. So it's 1.5 interquartiles above 346. That's 632.5. And the other one was subtracted below. So we do quartile 1 minus 286.5, which that's going to be a negative number because it's smaller. So 155 minus 286.5, negative 131.5. So anything outside these boundaries are considered outliers. So the question is, use the following sample of weights in pounds from 12 wild bears to determine if the weight of 416 would be considered an outlier. 416 is between those. It's not considered an outlier. It's only an outlier if it is above this or below this one. So this is not an outlier. Okay, the last part of this is a box plot, which you are using your 5-number summary. So I actually want y'all to go back to page 22, and I'm going to show you how to do a box plot from here. We already have the 5-number summary. So for the box plot, you make a line, and in the middle you're going to put your median. And this is on a number line. So think about a number line. And then you need to go back. So this is the median. Go back to quartile 1. So this is only 53. Quartile 3 is 100 though. So 53, let's say it's right here. It's Q1. 100 though is going to be, if that's only 4, oof, it's going to be all the way over here. So this would be quartile 3. And then you put a box around quartile 1 and quartile 3. You still have that line on the median. And so up here would be your maximum of 115. So that looks like it could possibly be 15. But 19, ooh, It's going to be all the way down here, I would say 19. So that's what a box plot looks like. Yeah, you can. Okay, so let's go. And this one's a lot nicer because we actually have a number line. This tells you how to do it. 5-number summary. Use a number line scale. Construct a box from Q1 to Q3. And then draw lines extending outward to your min and max. So we are going to use this. I don't know if we've done, have we found the median from this data set? I don't think we have. Due to time, I'm going to go ahead and just give it to you. Our minimum is 65. Our maximum is 98. We know that just by looking at it. Okay, quartile 1 is 91. We actually did find this on those percentiles right here. 91, 93.5, and 95.5. But you can also get this from the calculator. So let's go ahead and start with our min and our max. So 65, just put a dot on 65, right above 65. And 98. So these will be the whiskers. Nothing that is outside of those spots. Now, median is 93.5. So let's go up here. It's close to 94. Let's draw a line. Quartile 1 is 91. And then quartile 3 is 95.5. So this is median. Quartile 3, max, quartile 1, and min. So we've identified all of them. Now put a box, quartile 1, median, quartile 3. So that's your box, and then your whiskers go out to your mins and max, min and max. There's your box and whisker plot, or your box plot. And then our last part of this does tell us about how to put in a box plot on the calculator if you have your data there. So that is all for this lesson.